Good morning, students. I am Lal Navaratna from Ahmadiyya International School. Today I am going to do a lesson projectiles. Projectiles. So it is a part of mechanics. It is part of mechanics. So I am going to teach you projectiles. So when you are just starting about projectile, what is the projectile? The projectile will be a body which is thrown or fired from a certain point. So when you are just doing a projectile motion, so first we start when you are dropping a body from rest. When you drop a body from rest, so we know that it is moving vertically downwards with an acceleration of 9.81. So same way, if you just throw an object upward, it is vertically moving upward with a negative acceleration of minus 9.81. So this is, you can say, vertical projectiles. So the body in this type of motions, we are neglecting air resistance. Because of that, the body is acting only its weight. So therefore, we can use equations of motion. You know equations of motion: V equals U plus AT, S equals U plus V divided by 2 times T, then V squared equals U squared plus 2AS, then S equals UT plus half AT squared. All 4 kinematics equations we can use in projectiles. Then we see projectile. There are different types of projectiles. So first I am going to explain when the body is thrown horizontally. Say as example, you are throwing a body from a cliff top you are throwing. So when you are throwing the body from a cliff top, we see the motion. We know that, so as example, if you are just throwing a ball from a cliff top, it moves like this. The motion we call as, the path we call as a parabolic path. So we know that the downward acceleration is 9.81, then horizontal acceleration will be g cos 90, horizontal acceleration, that is 0. So during the projectiles, we can see that horizontal acceleration is 0. Therefore, the body is moving horizontally with constant velocity. When it falls to the ground also, the velocity will be u. There won't be any change in horizontal velocity because we are neglecting air resistance. Then vertical one we just work out. So when you are throwing horizontally, the vertical downward velocity will be 0, because you can see that u cos 90 will be 0. So downward velocity will be 0. So then due to the downward acceleration, what will happen? The body's velocity, vertical velocity component increases. Then if you want to find at a particular position velocity, say as example, I will denote this point as A. If you want to find the velocity at A, so we have to use a vector diagram and find this velocity. You have seen in many questions they are asking velocity at a particular point. When they ask velocity, since it's a vector quantity, we have to give the magnitude as well as direction. The direction will be, we can give to the horizontal or vertically. So now if you want to find the velocity here, what you have to do, you can just horizontal velocity u, vertical velocity v2, we can complete the vector diagram and this will be the resultant. So we can use Pythagoras, this is v2, this is also v2, then v squared equals u squared plus v2 squared. So v will be square root of this value. Then similarly we can find the angle by using trigonometry. Tan theta is equal to opposite divided by adjacent. So theta will be tan inverse V2 by u. Since when you are doing the questions, we know all the terms, so we can find the angle and resultant velocity. Right. So then there are some questions, students, they are asking to find the vertical height. If you want to find the vertical height, we can use downward equation S equals ut plus half at squared. So that means S will be h, u will be 0 plus half gt squared. So the time taken to fall will be t. In these projectiles, it's very important due to this motion. You can see when the body moves in a curved path, the vertically it is moving h, the horizontally it is moving x. You can see the motion. So vertical motion also there, horizontal motion also there. So that means these two motions are independent from each other. So the time taken to fall vertically and time taken to move horizontally will be same in projectiles. That's very important. If you want to find this horizontal distance, we can use horizontally equations of motion. If you use this equation, horizontal acceleration is 0, I have explained earlier. So S is equal to ut. Acceleration will cancel out. So then we can just substitute u will be u and time will be t. So we can find the horizontal distance. We call this horizontal distance as horizontal range. Horizontal range. Right. This is one type of projectile motion. Then we see there are questions. Now we know that in everyday life, in projectiles, we have many type of motions. Now a cricket player or batsman, when you hit to a ball, it will go in a curved path. Then we know that golfer, when hit the ball or hit the ball, it will go in a curved path. So in volleyball or basketball, any game, we know the ball is moving in parabolic path. So if you just take the path, so you can see this is the initial velocity, we call as velocity of projection. Then the angle we call as the horizontal direction or vertical direction, we can get the angle because velocity is a vector quantity. And then during the projectile motion, the first thing we have to do, we have to resolve this velocity to horizontal and vertical directions. So horizontal direction u cos theta, vertical direction u sin theta. That is the first thing we have to do. For this also they are giving the marks. So therefore we have to just with the help of a diagram, you can just show these things. So all this theta and u will be given, so easily you can work out. Then I explained that when the body moves in a curved path, downward acceleration is g, horizontal acceleration is 0. So therefore what will happen during the motion, horizontal velocity component will not change. Horizontal velocity component will not change. It will remain as u cos theta. Until it falls to the ground, it remains as u cos theta. The vertical component, what will happen? Gradually decreases. At the maximum height, vertical component will be 0. So that's why from there it will not rise vertically upward. So after the maximum height, so you can see here also velocity will be 0. So it is like exactly half of the projectile motion. The downward velocity gradually increases. So you can see only the vertical velocity is changing, horizontal velocity remains same. Then students, when you are doing, remember this is a symmetrical path, so therefore time taken to go up and time taken to come down will be same. So, t and t. So, then time of flight, that is the total time in air will be 2t. So, if you can find time, we can work out time of flight, because we can use upward equation from here. V equals u plus at, v will be 0, u will be u sin theta plus minus 9.81 times t, and from here you can find t. Then after that you can find time of flight. If you know the time of flight, you can find the horizontal range very easily, because we know that we can use directly s equals ut, because horizontal acceleration is 0. So, x is equal to u cos theta times t. So, that is the horizontal range. So, many questions they are asking these two parts, right. Then there are some important questions from projectiles. If you are just throwing a body from a top of a cliff with an angle, so earlier I explained the body is moving horizontally, now it is moving like this. This type of situations are there. Suppose you take a stone and you just throw it with an angle. We take the height of the cliff as h, then the initial velocity of projection u, then theta, then time taken will take t, will take this horizontal range x. So, then the first thing, horizontal component, vertical component, u cos theta, u sin theta, always we have to complete these two first, because they are giving the marks for these two parts. Then they can ask what is the height of the cliff above the ground. Okay. So, when they ask, we can use equation upward. I am using this equation. So, when I am using this equation, s will be h, u will be u sin theta into time of flight t plus half minus 9.81. It's a very important one, because I am using the motion upward. So, I have to put acceleration minus 9.81 into t squared. Now, students, when you are just substituting the values, you are getting h a negative answer. When you get a negative answer, do not think that you have done a mistake, it is perfectly correct, because when you are throwing upward, it is passing this horizontal level, the level of projection, and then it is falling down. Since it is falling down and this is displacement, it gives negative value, because displacement is a vector. So, we will get a negative value. Therefore, we can write height of the cliff, we can write directly positive answer. So, when you get a negative answer, that means you have used the equations correctly and you found the answer. So, this is another type of question you are getting. Then one more type is there, students. You can get a question like this. You are throwing a body and say suppose it will stop somewhere here. Then this is another way. Take this is h1, and then we will take this whole length as h2. The same way, initial velocity, angle of projection, u cos theta, u sin theta, then time t. You want to find, say as example, you want to find the say time, or you want to find some unknown term, so everything given. So, then if the body is moving from O to A, the vertical height we have to take as h2 minus h1. We have to take h2 minus h1, and then we can apply the equation. Say we are using any equations of motion, we can use s equals ut plus half at squared. So, s we can use here h2 minus h1, then u will be u sin theta t plus half minus g t squared. So, if the values are given, the unknown quantity you can find. So, these are the projectile questions you can get it. So, all the forms I have explained. So, then there is another important part is there. The questions are coming like this. Suppose a body is thrown with an angle and it lands like this, just below this surface like this. Maybe you have seen this question, long jumper is jumping, and then this type of questions are there. So, when you do this one, this is u, this is theta, u cos theta, this will be u sin theta. Then remember students, u cos theta will not change when it falls to the ground also u cos theta. When the body just hit the ground, the vertical velocity component also will be same as this u sin theta. So, you can see that how it is moving. So, you can use the equations of motion for this part separately and find this distance. So, this is like very similar to the motion we have learned like this. Okay? You know horizontal component, you know vertical component. Suppose they have given the vertical height, you can find the time and then you can find the horizontal distance. Same equations of motions we can use. Okay students, now we are going to do some past paper questions. I am going to do a presentation of some past paper questions. So, we will we have completed projectiles. So, I am going to start some questions. Okay, no? Right. So, here students please ask your questions using the following link. So, then projectiles. I have selected, since we have short time, so I am going to discuss about 3 questions. So, here the question you can see, 2 projectiles A and B launch from position O at the same time at time t. Both projectiles have travelled horizontal distance OP shown. You can see this question they have asked in this Excel paper, the horizontal distance and the times are same. So, you have to remember when you are doing the questions, keep it in mind the given data, horizontal distance, then the time same. Then you can see A initial velocity UA, B initial velocity UB, you can see that UB horizontal angle is 45, UA horizontal angle is theta. So, question given here, projectile A is launched with a velocity UA at an angle theta to the horizontal and projectile B is launched with a velocity UB 45 to the horizontal. They have given the clear data. So, we see how they ask in this question. Show that UA may be expressed in terms of UB. They have given an equation and they are asking us to show this. So, what you can do students, we know the time same, horizontal distance same. So, therefore, we can use directly S equals ut plus half at squared equation, but in this equation A is 0. So, therefore, directly we can use S equals ut. So, you can see I am using the arrow where I am using the equation, which direction. So, acceleration 0. So, S equals ut. For projectile A, you can see x equals UA cos theta, horizontal component we have to take. Then for projectile B, UB cos 45. Then 2 equations are there and we can equate these 2 equations because we know that 1 equals 2 because horizontal ranges are same. So, then T will cancel out, the time is common and UA is equal to UB cos 45 divided by cos theta and cos 45 is 0.707. You can see the required answer, we got it. Then the question asking, explain why for path of the two projectiles to be shown UA greater than UB, that means A velocity is greater than B velocity. So, we can use same equation, we can just use it UA over UB 0.707 over cos theta. Now, students, we know that from this angle, from the diagram you can see that theta angle is greater than 45. So, when the angle is getting bigger, cos value is getting smaller. So, you can see theta bigger than 45 means cos theta less than cos 45. So, that means cos theta less than cos 45 means cos theta less than 0.707. So, from the equation you can see if this is bigger than this is bigger than this. So, directly you can get that answer. You can see UB smaller than UA, that means UA bigger than UB. So, because the ratios work like that. Then on the axis below, sketch label graphs for vertical component of velocity against time for the motion of projectile A and projectile B between O and P. You may ignore the effects of air resistance. I said in my explanation, I said that air resistance we are neglecting. Then students, when you are drawing, you can see the graph of object A. You saw that object A in the diagram, the object A is still not reached to the maximum height. If it reaches to the maximum height, its vertical velocity will be 0, but it is not reached, that is why it will not touch the time axis. Then B, you can see it is complete projectile motion starting from a velocity, it will go to the maximum height, vertical velocity 0, then change the direction because velocity is a vector. When it is coming down negative side, and you can see that how it comes, and you can see the velocity is vertical velocity A, initial velocity u sin theta, B initial velocity, vertical velocity is UB sin 45. So, and the students, these two lines should be parallel because the gradient of the graph gives acceleration of free fall is a constant value. Then we are going to do question number 2, students. Here the photograph shows a cyclist performing a jump to produce a photograph. To produce the photograph, the camera shutter is open. Yeah. To produce the photograph, the camera shutter is open at regular time intervals. Right. You can see the picture. Here this is same like I explained that actually the motion from top of a cliff. You can see that how it comes. Then the question asking, with reference to the photograph, describe the motion of the cyclist as he performs the jump. So, cyclist travels at constant horizontal velocity because horizontal acceleration is 0. So, same horizontal distance apart in each image of the cyclist. Then vertical velocity gradually increasing due to downward acceleration. So, vertical distances gradually increases. It shows clearly from the diagram, and here this is given 4 marks for each 4 points. Then you can see part B, the path of the cyclist is shown. The cyclist takes off with a velocity 9.5 at an angle of 10 degrees to the horizontal. The total time taken for the jump is 1.8 second. Calculate the vertical height. You can see this one I explained for you in my theory class. You can see the diagram given 10 angle, then velocity 9.5. They ask in h, and you can use the equation directly, s equals ut plus half at squared in upward direction. So, once you can see that vertical component we have to use here 9.5 sin 10, that is 1.65, and then you can see acceleration minus 9.81. Put it inside the brackets clearly to understand, and you are getting h value minus 12.9. I said that when you get minus value, you have done the question perfectly correct. So, h you are getting minus means the height of the cliff should be plus 12.9. Then calculate the horizontal distance jumped by the cyclist. If you want to find the horizontal distance, we can use directly S equals ut. You can see that horizontal velocity will be 9.5 cos 10, horizontal acceleration is 0. So, therefore, directly we can use S equals ut and you will get 16.8. Then C part, the cyclist briefly has a feeling of weightlessness during his jump. Explain why. Why he is having weightlessness? Because when the cyclist jumps, he will experience only one single force, only his weight, and he is losing contact with the cycle. So, therefore, no normal contact force. So, no normal contact force. So, there is no normal contact force acting on him from the cycle, the acceleration of the cycle and cyclist same value. So, no contact means only single force is acting on the cyclist, that is his weight. So, he will be under free fall and he feel weightless. Then in a game of cricket, a player hits the ball which takes path P. Air resistance acted on the ball as it travels through the air. If there were no air resistance, the ball would have followed path Q. Now, you can see the two paths are there, path P and path Q. Path P when there is air resistance, path Q when there is no air resistance. You see what they ask in the question here. Draw a free body force diagram for the ball when it is at the position mark X. So, the ball in path P will experience weight as well as air resistance. Since it is moving in tangential direction, the air resistance will be to the opposite direction. So, you have to mark two forces labeled arrows. Explain the difference between path P and Q. We see that how we can give the answer. I have given very short way. Different between paths. When you take for path P, horizontal range is less. That is because of horizontal velocity decreasing, horizontally decelerate we can say, because of the air resistance. It will take shorter time to move that distance. So, horizontal range is less. Then maximum height reach is slower because we can see here also what will happen due to downward deceleration. What will happen, due to the weight, it will decelerate, the body will decelerate, so it will not rise to the same height. Then the ball was given initial velocity of 35 meters per second at an angle 25. The horizontal distance from the player to the boundary given. The player scores 6 runs if the ball lands beyond the boundary before it bounces. Determine whether 6 runs be scored. We see that this is the last part of the question, how we can finish this. So, what you can do, first you have to resolve the velocity 35 cos 25, 35 sin 25, and we can apply horizontal first vertical motion to the maximum height and find the time of flight. See that V is 0, A is minus 9.81, time comes 1.51, then time of flight will be doubled because symmetrical diagram 3.02. Then we can work out the horizontal range, S equals ut, u will be 35 cos 25 and time will be time of flight 3.02, 95.7 comes. It is greater than 85, so 6 runs scored. Horizontal range, you can see that horizontal range 95.7 is greater than 85, so the player have scored the 6 runs.